Hi students, I am Sumulata. In today's class, I am going to teach you about hydrocarbons from carbon and its compounds. It is the class 10. Before watching this video, just try to watch my previous video, that is versatile nature of carbon. Then only you can able to understand what I am saying in this class. And one more thing, just try to watch complete video. Then only you can able to get clear information after watching this video. If you feel it is informative and useful, then share these videos to your friends and like and comment, mention your words in comment box. If you have any doubts, then post your doubts in comment box also. Then coming to our topic, why we are called them as hydrocarbons? Why not oxocarbons, or why not sulfocarbons, or why not nitrocarbons? We are only calling hydrocarbons. The reason because the compounds which are having only carbon and hydrogen, those are nothing but the hydrocarbons, students. Why only carbon and hydrogen? Why not other elements comes under as a hydrocarbons? Because of the main reason is electronegativity difference between these two atoms is the very less. Okay, because of that reason no one is acting as a dominating. Okay, I mean carbon don't want to dominate hydrogen and hydrogen also don't want to dominate carbon. They both are having mutual understanding. Carbon said to hydrogen, hey hydrogen, I have 4 electrons in my outermost shell, so that if I share my 4 outermost electrons to 4 hydrogen atoms are with you, then I will get octet configuration in my outermost shell. So then I will get the neons configuration. I will become the stable one. It is thought like that and explained to hydrogen. At the same time, hydrogen also tell to the carbon, hey carbon, I have only 1 electron in my outermost shell. What is the use? If I get 1 more electron, then I will get neon helium's configuration. That is the noble gas configuration. Then I will able to feel free. Hey, I also get octet, I mean noble gas configuration. No one can able to disturb, can able to come disturb me, like that. It will also think. So that both are having mutual understanding like this because of their less electronegativity difference. What do you mean by electronegativity? Electronegativity is nothing but dragging of electrons or attracting electrons from other elements. Then that electrons are known as that elements are known as the electronegativity elements. If any element share their give their its electrons to other elements, then that element will become the electropositive element. But here these two are not acting as a electropositive or electronegative while forming the hydrocarbons. Both are having good friendship. Because of this because of this reason they can form more number of compounds. Those are nothing but the hydrocarbons. Now we will see about, is there any classification about hydrocarbons? Yes, it is a classification. What is that classification? The classification is that is, first one is, hydrocarbons are classified into open chain hydrocarbons, and another one is closed chain or branched chain or ring hydrocarbons. This is one classification and this is the another classification. This open chain hydrocarbons are of 2 types. Those are straight chain hydrocarbons and the second one is branched chain hydrocarbons. Okay, you can take one example for straight chain. I am going to take N-pentane, CH3, CH2, 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 CH3. See here students, all carbon atoms present in this N-pentane are attached in the same line, within the line only. See, so that it is called as a straight chain hydrocarbon. You can take one example for branched chain, CH3, CH, CH2, CH3. Here See, this carbon acting as a branched carbon. So it is the branched chain, it is the straight chain hydrocarbon. Here 4 carbon atoms are attaches in straight chain, one more carbon acting as a branch. Okay, this is about open chain or branched chain. Closed chain hydrocarbons, you can take one example, CH2, 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 CH2. See, this is a cyclopentane. In the same way, cyclopropane, cyclobutane, anyone you can take. Okay. Again, these two compounds can able to classify or not. We can able to classify. These, this open chain and closed chain hydrocarbons again classified into 2 types. The first one is saturated and the second one is unsaturated. What do you mean by saturated hydrocarbons? Saturated hydrocarbons are nothing but hydrocarbons are having carbon-carbon single bond. Those are the saturated hydrocarbons. To this one you can take all alkanes comes under as a saturated hydrocarbons. Okay. Alkanes are having general molecular formula CnH2n plus 2 students. This is the general molecular formula of alkanes. I want to give you one example here. CH3, CH2, CH3. This is the propane. Okay. Then butane, pentane, hexane, heptane, all maybe are branched chain or open chain. Okay, all will comes under as a saturated. All are having single bond only, carbon carbon. Again, coming to these unsaturated hydrocarbons, these are of 2 types. The first one is carbon carbon single bond is there, that is one type. If carbon 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 double bond is there, that is one type, and carbon carbon triple bond is there, that is another type. What do you mean by double bond? That is alkenes. Double bond is there, those are the alkenes. If triple bond is there, those are the alkynes. Example for general molecular formula for alkenes, CnH2n. Example you can take propene, CH3, CH double bond CH2. This is the propene. The previous one is propane. This is propene. You here coming to alkynes, general formula CnH2n minus 2. For example, this one propyne, CH3C triple bond CH students. This is the propyne, CH3C triple bond CH. This is about general classification of hydrocarbons. Only these are having carbon and hydrogen molecules. There is another classification also. Though that in that classification, along with carbon and hydrogen, other elements also there. What are those? We will see now. Okay. Before that, see what is the use of alkanes and alkenes, hydrocarbons. See here, alkenes, we are going to use alkanes as a wax coated material on fruits. Because of this coating, fruits will retain their moisture, so that we can prevent fruits from spoiling. In the same way, this wax coated material prepared from solid alkanes only, not gaseous molecules. Coming to next one, the density and viscosity of alkanes will depends upon their molecular weight. If molecular weight is more, then the density and viscosity will also be increases. Coming to alkenes, in alkenes especially you can take ethene students, CH2 double bond CH2. This is the ethene, it is the gaseous molecule. It is used for the ripening of the fruits, and it will produce from the ripening bananas also. Because of this reason, we should not keep other fruits and vegetables with this bananas. If one banana will going to be ripening, that will produce ethene gas. Because of this that ethene, the remaining fruits and vegetables will also become spoil. Okay, this is about merits and uses of alkenes and alkanes. Okay, coming to next classification. See, the next classification mainly depends upon the functional groups. Functional groups. How can you identify functional groups? Functional groups we can identify it by if carbon form bond with along with hydrogen, if any other atom like hydrogen, nitrogen, sulfur, oxygen or halogens, maybe etc. If it will form, then functional groups will be formed. What are those functional groups? We will see now. Actually, if you take an hydrocarbon or carbon compound or any organic compound, the characteristic feature of that particular organic compound mainly depends upon the atoms or groups present in that compound. Those group of atoms or particular atoms are known as the functional groups. Now we are going to what are those functional groups? Those functional groups are, the first one I am going to tell, if any organic compound having carbon, hydrogen along with them, if halogen is there, then how can you identify what are those organic compounds? What is the representation of that functional group? See here, that one is carbon, hydrogen along with halogen, X. Here X is the fluorine, chlorine, bromine, iodine. These are the halogen elements. So, if these elements are there, what is that organic compound? That organic compound is nothing but halo compounds. Halo compounds. To that one, what is the functional group representation or organic compound representation? For this one, RX. See, here it is, R is the hydrocarbon or alkyl group. That alkyl group is having same carbon and hydrogen. This X is the halogen atom. This one you can take one example, CH3, CH2, CH2, Cl you can take, propyl chloride. Okay, see here it is the 3 carbon atoms and 1 chlorine atom is there. You can take ethyl chloride also, or chloroethane, here also chloropropane, like that you can call. Coming to next one, these are the halo compounds. Next one is, if along with carbon and hydrogen, if oxygen is there, how can you classify? How can you identify those organic compounds? Here number of functional groups are adjust with these 3 elements, alcohols, aldehydes and ketones. These will comes under as a esters. These are also comes under as a carbon, hydrogen and oxygen atoms present in that particular organic compound. See here, first one is, if carbon, hydrogen and oxygen is there, the first functional group I am going to tell. You can take one water molecule, students. In this water molecule, if one hydrogen atom of this water molecule replaces with the alkyl group, then you will get the alcohol. See, it is the alcohol, ROH. R is nothing but alkyl group. This is the alcoholic, the organic compounds having OH functional group, those are comes under as a alcohols. The organic compounds having halogen functional groups, those are the halo compounds. Okay, next one, if carbon, hydrogen and oxygen, if these 3 these three atoms present like this, CHO. This is one functional group. This functional group is nothing but aldehydic functional group, aldehyde. So here we can represent this one RCHO, RCHO. Here R is the alkyl group, is either methyl, ethyl, propyl, anything you can take. Coming to next one, if esteric functional group is, before that one you can take ketone functional group. If hydrocarbons are having C double bond O C functional group, this is the ketonic functional group. So if it is present in the hydrocarbons, those are nothing but the ketones. Those particular compounds are called as the ketones. Here it can be represented with RCOR. Here R are nothing but the alkyl groups. These may be different or similar. If those two are similar, R you can take. If those two are different, you can take R and R dash. If similar, those are maybe methyl, those are maybe ethyl. If different, one is methyl maybe, another one is ethyl maybe. Okay, this is the ketonic functional group. Next one is esteric functional group. In water molecule, you can replace these two hydrogens with alkyl functional group, ROR. This is the ether. See, COC functional group. Okay, if it is CH3, imagine dimethyl ether, it is the dimethyl ether. And the next one is esteric functional group. Before ester you can take acid, carboxylic acid. If the functional organic compound having COOH functional group, that is the those compounds are called as the carboxylic acids. Here R is the alkyl group. See, CH3COOH. This is the one carboxylic acid. In this carboxylic acid, if you replace this hydrogen with alkyl group, you will get the ester. See, this is the ester. These two are maybe similar or different. RCOOR dash. You can take an example, CH3C double bond O CH3. CH3C double bond O CH2 CH3. See, here it is the ethyl methyl ester. This is the only dimethyl ester. One more functional group, that is carbon, hydrogen and nitrogen. Carbon, hydrogen and nitrogen is there. How can you identify that functional group? You can take ammonia. In ammonia, if you replace one hydrogen, that is primary amine, RNH2. If you replace two hydrogens, R2NH, secondary amine. If you replace three hydrogens, that is the tertiary amine. This is the hydrocarbons having NH2 functional group, amino functional group. These are about classification based upon their functional groups. Now going to another one is homologous classification. Or what do you mean by homologous series? If you take any successive two compounds, how can you how can you differentiate those two compounds? See, suppose I am going to take CH3, C2, H6, C3, H8, C4, H10 students. Here these two are the successive compounds and these two are the successive compounds. These two are the successive compounds. What is the difference between two successive compounds. See, if any two successive compounds are having CH2 unit only the difference, then those are comes under as a homologous series. So here these two are having successive unit, difference is the CH2, here also CH2. So these are all alkanes, these are all alkanes. This is about homologous series. And you can take C2H4, C3, H6, C4, H8, C5, H10 students. Here also only difference between successive units CH2. Successive compounds CH2 unit is the only difference. In the same way, C2H2, C3, H3, sorry, C3H4, C4, H6, C5, H8. These are also having different CH2 unit. These are all comes under as a homologous series. Homologous series. These are all the homologous series. In the same way, I mean, these are the alkenes and these are the alkynes. In the same way, in alcohols, ethers, esters, in all those compounds also, all alcohols are having homologous series. I mean, ethyl alcohol and methyl alcohol. Methyl alcohol, ethyl alcohol, both are having CH2 unit is the differentiating one along with one oxygen. In the same way, ketones, aldehydes, all organic compounds are having. I mean, the organic compounds should need to belong to the same one. Okay, same series. I mean, see, these are all the alkanes, these are all the alkenes, and those are all the alkynes. In the same way, all alcohols, if you take from methyl alcohol to etc., all are having differentiating unit is the between two successive compounds, differentiating unit is the CH2 only. Like that, we can call the homologous series. Yes. Here, this is about hydrocarbons and their classification depends upon their functional groups. I hope you are all understand about this lesson. Thank you, children. We will meet in the next class. In that class, we will go to discuss about nomenclature of organic compounds. Just be ready with that one. We will catch you in the next class. Bye, students.